Hi, folks. Hi. Good evening. Good
Hey,
morning.
good evening, good
Hey,
morning.
how are you?
Wait, you are not in the this is not a friendly time for you, so props to you for making it making it this late for you.
It's fine. It's fine. Yeah, I actually slept 2 hours actually this afternoon, so it's actually fine for me. Yeah.
Okay, that's good. I don't know if the schedule change got people confused and they didn't realize there's a meeting now. Um,
But I
I
mean,
might
I get the invitation. I get the um invitation, right? So I suppose others should get as well, right? So
they should get it, yeah. So I will
um
if nobody I'll give it a couple more minutes so if people don't show up. We can just we can have a discussion about some stuff about this, and then we'll try to sync back again next time in 2 weeks, and that'll be the kind of Europe friendly, more Europe friendly time. Although
yeah,
somebody exclaimed, they said it's Friday evening our time, so it's not that friendly. I'm like it's at least not in the middle of the night. That's about the best I can do.
or be online. I can ping him. If there's more people coming, I can ping him. So he's super
Jacoby.
busy man.
Okay,
Yeah,
yeah,
yeah, he's super busy man. I would just say if more people is showing up, I can probably ping him.
okay.
Uh,
I mean, yeah. Most of the discussion, I'm not sure is rel. Well, we'll see. I mean, we're still talking about some beginning things. Um, but I don't even
mhm.
see the Intel folks here. I ping them too. I see Dufan joined. Yeah, so other people are getting the invite. But I guess we just have a short meeting today. Um, I'll I'll go through some topics. I think we can still have a conversation about some of these things, and then I'll try to figure out what happened with other people. But let me share what I was going to share today.
Ruby said he didn't get the invitation as well, so I'm forwarding the invitation to him.
Okay. Um, So yeah, we're just gonna miss a whole bunch of people today, and uh, I'll just go through what I got, and yeah, and then we'll have to sync up again after that. So but otherwise, is the screen share looking okay? Can people see it? Do I need to make it bigger or anything?
Yeah, I can see.
Okay, sounds good. Okay, so this is welcome to another edition of this device security call. That's actually the kernel SIG, but for the foreseeable future, it is going to be focused on this upstream enabling, cross-vendor upstream enabling for uh, device security. I see Gobi joined too. Perfect.
Here then.
Hey, and so I was expecting some new people this time, but I think everybody who's joined now has been on the call before, or maybe Dufan hasn't been here before. So I'll quickly go over these again. This call is recorded. It's actually the videos are posted on YouTube, so don't say anything that you don't want on the internet. But also, it's pretty easy to accidentally start talking about things that are PCI SIG confidential or maybe your product timeline confidential. So just be wary. Don't mention those details. Try to keep it to everything that you would say on a public mailing list is everything we want to talk about in here. Um, we do have the Discord chat, which hasn't really been used by people. Like the CXL folks use that Discord a lot. I haven't really gotten too much engagement on Discord, but that is there for other kind of ad hoc conversations. But also, this is supposed to supplement what happens on the mailing list, and any decisions that we come to really are going to be those are going to be documented on the mailing list. We're not going to. This isn't a decision forum. We don't vote on things. This is another higher bandwidth way to get through some of the backlog of things we have to get through. So this started off as an Intel call, and then we created this kernel SIG within the Computational Computing Consortium, and I'm monopolizing the agenda for these first few months while we get some of the kind of I call it major combat operations completed on getting some of the fundamental device security things upstream. But I'm open to using this space for other topics that people have, and so that's an open invitation um, to go ahead and send me topics if you want to get things on the agenda, and we can get those on there. But in the near term, it's going to be very much a discussion between folks from. It really looks like on the mailing list, the people that are kind of ready to start talking about this are Intel, AMD, and Revos. I know ARM is starting to post some stuff there, but yeah. So this is really about game planning how we go to people like Bjorn, the PCI maintainer in the near term, and then Sean and Pablo later on once we get into the more KVM specific side of this. But there's still this hump we have to get over in terms of the kind of the PCI core ABIs and what that looks like. Um, but before I jump into what I want to talk about today, and we might not get that far because the people I really wanted to talk to that kind of need to come to consensus with is are the developers that have been working on the AMD kind of POC minimum viable product implementation and the same folks on the Intel side, so that we can kind of uh, what we have is a common infrastructure proposal from me, and I either need to either be told where that thing is broken and change it, or they need to convince me to go pick up what they were doing in their POCs. But we basically have three implementations out there that need to reconcile so that we can come to Bjorn with a common proposal. Like this is the infrastructure that Bjorn. I mean, this is the infrastructure that two or three vendors agree upon. And so Bjorn, go ahead and spend your time on this versus him having to ask us to do it anyway. Because if we come to him with two different proposals doing similar things, he's just going to ask us to work together anyway. So that's why we have this call to get to prefetch that work. But before I jump into this discussion of where we're at with the upstream staging and what are the topics are top of mind for that next, are there any opens or or introductions. I think everybody's had a chance to introduce before, I'll pause here for any opens. Um, okay, no opens. Okay, so this basically this is going to be a slide like this is going to be our agenda for the next few calls. And in terms of and I expect we're gonna walk through this in as as far as the upstreaming goes. This is also kind of the order of things that are going to be upstreamed. And currently, I don't think I have a. I don't know. Can you see my mouse moving around? If not,
Yes, yeah, you can see it.
okay, okay. But so
Yes,
currently,
yes.
currently we're not even here yet. Like in the sense that we haven't even got this kind of core definition of this thing going. But uh, in terms of having a consolidated approach that we want to take to Bjorn, and so I posted the RFC of, hey, this is what a combined thing looks like, and got some feedback. I do owe another posting of that incorporates that feedback to make some of the stuff more real for folks. And then try to get at least one of the existing POCs to switch over to it as a proof of concept to say, yeah, this does everything that we need, and it can be used for both the Intel thing, the AMD thing, and the Revos thing. Get that kind of agreement. So I do owe that. I was hoping to have a conversation about any concern, like status or concerns about switching over to that, but we'll save that for later. Uh, so this thing is going to centralize in the PCI core doing the connect verb. So we talked about it, plumbers. We were going to have a set of kind of common and coarse verbs, and one of those verbs is going to be connect. And connect is things like SPDM session establishment, IDE establishment, and collecting some measurements. What has happened recently is also that the native CMA patches, so component measurement authentication, basically authenticated devices natively without needing to talk to the platform TSM. Those patches have made progress and have proposed some ABIs that we would do well to just share, in the sense that if the native CMA code has an ABI for indicating that the device is authenticated, we would reflect the same status through that thing for the TSM connected case, things like that. Uh, once we get to that common definition in the PCI core that works, and we have at least one low level implementation converted over to it, then I think we'll be done with kind of this phase one, and probably ready to start having the even more complicated discussion about private memory and all the different ways that different vendors manage private memory and private devices, and that has much more kind of KVM implications than PCI core. A couple of details that have come up as I'm looking at this. One last time we talked about this. I'm thinking about this policy of, oh, if the kernel has native authentication, then that should be a prerequisite step before you trigger connection to your platform TSM. And what through the discussions, like one of the changes since last time we talked is, I don't think that needs to be a kernel policy. That can definitely be a user space policy, and it allows us to disconnect from that patch set, in the sense that we can work on the TSM patches independent of the CMA patches. And so the um, the ABI would be shared. Like we would still have this authenticated state of a device that user space could write policy upon, but enforcing whether it needs to be authenticated natively before it can be authenticated connected via TSM, that's a policy that user space can enforce if it wants to. User space is free to just say, I don't care about native authentication, I'm just going to connect to um, to the platform TSM, and basically let Linux distributions set that policy of whether the distribution says no, we need to make sure that the certificates are distributed to us, and we have a way to authenticate devices before we would ask them also to be connected and go through this platform TSM thing. So that lets the kernel basically that's also useful because it lets the kernel avoid a kind of a controversial policy decision and just pushes it out of user space, which is kind of a general kernel tactic of only mechanism in the kernel and policy in user space. But some of the useful things that have happened in the CMA space is people have started. So Lucas presented CMA at Plumbers, and one of the feedbacks he got, and this is one of the things I wanted to talk about today, is that the people asked him, "Hey, please build an ABI that allows user space to validate the transcript." This is the transcript of all of the SPDM messages, get version, get certificates, all of that back and forth conversation. SPDM has you capture that as a transcript, and it can be signed at the end with a or digest at the end, and there could be a nonce included in that, so that a verifier can say this is a transcript that happened recently. I provided the nonce. I know it's a fresh transcript. I know it's a fresh session, and can verify the whole thing. The question uh, um, is what does that ABI look what does that ABI look like, and I guess more importantly is, do we need an ABI for specifying the nonce that goes with that transcript? And this is where I was looking for some opinions from people about what what needs to happen here, uh, or what Linux needs to prepare for. I know Lucas, he was he was of the opinion like why like the kernel has its own trust and its own entropy generator. It can generate nonces, and it can just tell, and it can definitely communicate that it picked a suitably random nonce, uh, and the verifier would have to trust what the kernel picked versus allowing the nonce to be specified, because that requiring this nonce to be specified really interrupts the flow in the sense of it's hard to inject that setup step and that parameter into the places where we want to set this policy. So like I'll give an example. The device is going to go through PCI enumeration, and there's also going to be some kind of platform enumeration of the TSM of the TDX module or the SEV-TIO firmware or what have you. Those things are going to happen asynchronously. When those two things, at some point, there's going to be an event that fires um, that those that the device is discovered and the TSM is up, and so a UDEV rule can basically sit there and wait and say, okay, I have everything I need. I have a TSM. I have a device with the capability. Now I can deploy my policy of do I want to connect this device or not, because I'm going to use this device's virtual functions to define TDs. Now that process is like a UDEV rule. It's a static UDEV rule. It's a policy. It really doesn't have a chance to go back out and say, hey, what should be the nonce I should use for this device for this connection attempt? So if you say, so it basically it would be nice just from an interface perspective of not having to require that. Um, but then the question is that sufficient? And do we still need another way to maybe recollect measurements or like get this transcript again, but with a user supplied nonce? Um, that's where I'm kind of looking for some feedback. if that question makes sense about what Linux needs to do. Oh yeah, go ahead, Gobi. Yeah, so yeah, go ahead and raise your hands. But I think
Sure,
we're a small group today, so I think you can go ahead and just come off mute and start talking.
sure. I have two comments, Dan. One, on the aspect of the measurement collection. There are use cases that requires measurements to be collected at init time and also at runtime.
Does that
Right.
so when you does that include the does that include the so I know about measurement collection, like the actual SPN measurements. It also that do you include transcript in that, like SPN
Correct.
setup transcript?
You cannot validate the measurement report without getting the transcript.
Okay.
Right. So the transcript is passed all the way up to the who is actually verifying the report. Yes. So the other question of, can the nonce be generated at the kernel side? Is imagine a case where the relaying party is outside the system itself. Today we support a local relaying party, but in the future, the relaying party is going to be the remote system. If you don't have the remote system generate the nonce for you, then there's the whole attestation report is prone to replay attacks.
Yeah, like that was a question I had for that was a similar question I had for Lucas. Like even if you trust the kernel to do it, you really have no guarantee that something happened, or maybe for some reason two guests there's some kind of attack where both guests entropy pools are identical or something, and you're trying to attack the other one and get the
Correct.
impersonate. Yeah, you're right.
If you have the kernel generate the nonce, then we need to build a secure channel from the remote relaying party all the way to the kernel, so that the whole interface is not is actually replay protected. It's
But
going to be a much more
maybe,
tricky situation,
maybe-
right? So the best option is to have the relaying party generate nonce and send it all the way down to the device.
I'm
Yeah,
wondering. Oh, is somebody trying to say
yeah,
something?
I was just gonna agree with Gobi that we ca- if you're talking about the host kernel generating any of this nonce material, then we can't really rely on that, right? For the reasons Gobi mentioned. So,
Okay.
it should be coming as a challenge from the relying party, um, or if it's something that an object that the guest is generating, then it should come from the guest kernel. So in both cases, it should be those two endpoints, not the host kernel.
Ravi, even if it is the guest kernel, right? So we cannot expect the guest kernel to also be the relaying party.
No, no, not the relying party. There are some exchanges in which you might want to generate some freshness of messages going back from the guest. And I'm saying in that case,
Okay,
it has to be the guest generating that.
sure.
So those are the two endpoints that have to generate the nonces, not the host kernel.
I'm guessing. Like I think because we have this UDEV policy is basically going to fire this. That's going to fire and say TSM present, device present. What do you want to do about it? I think that because that's in user space, you could actually just say that there's a sysfs attribute that takes the nonce. Um, would it be okay if the kernel also mixed in its own nonce with the relying parties provided nonce, just so that uh,
We can.
as
You
long as
can have the relaying party provide one part of the nonce and kernel attach its own as the second part. It's entirely possible, but we are talking about a custom protocol there.
okay.
Yeah.
I mean, yeah, because so with Linux already has this TSM report ABI, which takes just a 64-byte binary blob as input, and we could do the same thing here. Is the not 64 bytes in this case as well,
Yeah,
or is
correct. 256 bits, correct.
okay? Yeah. So I think like just we would just have a sysfs ABI that if you don't write it before you do connect, the kernel will pick a nonce and tell you what it picked. And if you do, if you write that before you trigger connect, then it'll use the value that user space provided.
And when you
And,
say connect, is it just one time connect? Whereas now there could be multiple calls coming in for attestation report.
uh, so right now I'm talking about the physical device connect event, which is just one. That's one per physical device.
Correct.
You and then then I expect there's going to be a measurement request per virtual function once those things are assigned.
Correct. And even within the virtual function, you could have the measurement report request multiple times based on the use case.
You could have the measurement report requested multiple times. Yeah. So you expect as a relying party that when that's triggered, you'll get a new measurement. You'll have it will include the transcript from the physical function setup as well as the per TDI measurements.
That's something, that's something we have to figure out. Can the transcript lead to any leakage or the cross VF contamination? We have to discuss that. So far, it doesn't look like the case, but if transcript leads to any data leak, then we need to figure out a way to actually mitigate the problem.
Is that in the current public TDIF spec about what's included in that, or is that
no?
That's
the TDIF spec do not,
a per TSM choice about what it includes.
Correct.
Okay.
Yes. Now on the SPDM working group, we asked, we requested a standalone get attestation API, without including transcript. That could, resolve some of these problems that we're talking about now, but we couldn't get that passing. So for now, the only option is to get the transcript along with the report.
Okay.
Yeah.
Can I ask a question? I'm sorry, I did not find the button to raise a hand here.
Sure, no, probably. It's actually, yeah, you have to hit the smiley face, and there's
the reaction. Thank you.
No problem.
So when you say that the nonce could be generated from an external entity, do you guys envision what entity would be that? Would that be something related to I don't know, key broker server or any other kind of trusted entity?
Yeah, it could be a key broker server, or it could be a remote verifier, something like Intel Amber or Microsoft Azure Attestation Service, right? Any of those that an user entrust for either key storage or for the verification. One of those entities, yes.
Okay. Follow-up question is, so if an external entity generates a nonce and the kernel also kind of has its own nonce that could be, for example, appended or somehow added to the request, does the generated attestation report will need to be replayed to confirm that, oh, that was the attestation report I requested? Because if the kernel also adds its own, it would be difficult for an external entity to replay that request.
I don't see a huge benefit in kernel appending its own nonce into the mix. Dan, what was the motivation for doing that?
I think so. The only motivation I think was this idea that the kernel can understand the provenance of the nonce, and that somebody didn't just specify 42. That there's some, the kernel knows that it got the nonce from an entropy source that is validated. But at the same time, the kernel's already kind of crossed that threshold of allowing bad quality nonces if it wants to for other ABI. So I think it's kind of too late to say, oh, well, this one needs a good high quality nonce. At the same time, though, this is all, as far as the kernel is concerned, this is all a user space problem, in the sense that as long as the kernel communicates that, then you could have a protocol back to the relying party that says, oh, by the way, I XORed in my own nonce, and here's what I XORed in, and the relying party can verify that happened. But yeah, I would argue, I would push for the kernel not doing that, just because the benefit is not clear. And
and in long term, the attestation calls may not even go through the kernel, right? If you think about in the long term, with Intel TDX partitioning, you can have a separate TD partitioning managing all this attestation without even bothering the guest kernel at all, right? That is a possibility in long run.
I mean, like you're talking about without bothering the L2 guest, but the L1 guest would still be
Correct.
involved.
Yeah, L1 guest.
Yeah,
Yes.
yeah,
Yeah.
yeah. No, that makes sense. I guess the concern is whether all TSM implementations allow a nonce to be specified, but that's simple enough to handle from the kernel side to say if the attribute to allow the nonce to be specified is not writable or not present, then you know that you're in an environment where the relying party is not allowed to provide a nonce, and you get to make your own decision about what that is. But otherwise, basically, like there's going to be some of this standardization, I think, where we kind of need vendors to agree and make sure that their TSM APIs allow for the same flexibility. And I think there's going to be other cases where Linux is going to enumerate what the TSM platform supports, and it may be a mixed bag across vendors for some of these things. And I think that's going to have to be okay. Maybe especially in the near term, if some of these implementations still need to like grow that capability that they didn't think was needed before. As far as I know, I'm not aware of any implementations that don't allow providing the nonce, but that's just kind of a thought experiment of like thinking through an ABI that may or may not have 100% support, but you can user space can at least discover what's happening there. But the idea here is definitely to make this a distribution problem. Like your Linux distribution or like the physical host is responsible for listening for these events and triggering connect with triggering the connect verb with whatever parameters are required, and reporting whether connect was successful or not. And the actual low level details is kind of is abstracted. Okay, that was useful. Yeah, I think I have a better idea of what transcript will be used for. And let's see. And just make it optionally injected at attach time. But we're also going to need the same for the later on collection case where
Correct.
You might need to do nonce injection here as well. Okay. Okay. So the other thing that's come up is the idea, and like if you look at some of the implementations, like IDE is actually kind of hidden on some of these TSMs, and I like that idea that IDE is not. Basically, you trust the TSM to say whether your connection to the device is secure or not, and maybe it uses IDE, and maybe you can see some IDE attributes behind the transport, but it doesn't necessarily need to be that way. I'm thinking of things like the TDIS spec says that TDIS spec allows for the case where like consider like an integrated device, where you know that you would have to delid the CPU and get a focused ion beam in there to try to see the traffic that the TSM may say that's secure with there's a secure link to this device without IDE. And so for the PCI core integration, I'm thinking that the TSM will allow attempting to connect to any device that either says it supports IDE or it says it supports TDIS, and then just let the TSM have the final say on whether you can connect or not, and then go from there. I don't think anybody has any concerns about that or questions about. I guess what I'm going for here is just talking through making sure that all the ways that people might want to use this connect verb that we consider, because if somebody produces a device that supports TDIS or supports IDE without TDISP, I think we do want this, what we're building here, to be useful for that case as well.
No, are you talking about IDE without TDISP?
Yeah.
Both cases, right? You could have devices, IEP, RCIEP devices without ID but supports TDISP. You're
Correct.
talking about both the cases. So it's going to be
I guess,
TSM policy.
yes.
Okay.
Yeah, yeah, and that the Linux driver would have to be prepared for all those cases. Like I think, like I saw in one of the implementations, like the TSM driver wouldn't even try to attach to the device if it didn't support TDISP, and I think that's wrong. And also there's some implications about key management, key refresh, the algorithms for IDE that aren't important if the device is secured by some other mechanism that's not IDE. So it's making sure the interface allows for that kind of flexibility.
Sure. And maybe the another question is, how do you expose all these TSM policies to the end users? Would it be in the attestation report?
I don't know if, like, you mean like the policy of whether it can connect or not, or
No, whether the interface is ID protected or not. If TSM is allowing TDS to be established with a device even without IDE, would that policy be given to the end user for them to make a call whether to test or not?
I don't. My feeling is that we would not, that you trust your TSM to do everything, that and so that if you ask it to do the connect and it says yes, then basically you get to keep all the pieces if the TSM is made the wrong decision, kind of thing. I guess let me say a different way. Like we need a use case to say, like, when would user space want to know that ID is not there? I think we could probably definitely figure out a way to expose it. Just whether we have a use case for that. Or maybe like IDE is optional, and you want to make sure that IDE was there. Something like this.
Correct. Yeah, something
Yeah.
like that. Yes. Yeah.
Yeah.
And it would be in the end, sure, the user is trusting TSM to do all the connections, right? But the trust and verify is something that the end user and the relaying party must do, and they should have all the information to make that call.
Right. Right. Like I know that TDISP has some kind of enumeration of things like ID ATS is supported or not, and these kind of enumerations.
Yeah.
Like I think we do need to emit that somewhere to say the TSM negotiated a connection with this device with these parameters. It turned off ATS. It turned off IDE and completed this connection. That kind of thing. So it'd probably be just a read-only attribute that says IDE, like for each kind of, probably everything in that TDISP capabilities list. I'm not sure what it's called, but just have a yes/no flag for each of
Yeah.
those. But I don't know if that would be in the attestation report. That would be in the user interface, and so your
Correct.
relying
Yeah.
party would have to trust information coming from that host that may not be included in the attestation report.
Sure. There's no standard format. I mean, the format is standard, but what states to measure is not standardized today, right? So it could be up to the device vendors and TSM vendors to include all the policy details into the attestation report as well. From the GPU side, we will include ID state into the attestation report for sure.
Okay.
Yeah.
But in that case, like that's really that can be a conversation between the device and a contact between the device and the relying party. The Linux would no Linux just said, yeah, I connected, and the verifier says, oh, hey, the report I got back from the device's ID is turned off. I want to make a different decision about
Sure.
this
Yeah.
device.
Yeah. That's entirely possible.
So yeah, so that's where it gets to like um, when it comes to like proposing the kernel APIs. It's a hey, if we can get by without it, let's try that, and then if it becomes clear that it's not that you really do care about what the host said and not what the device, like the host adaptation report, um, then or like the host side was a specific part of the adaptation report, then we can figure out if we want to expose that in the ABI or not.
Sure. And is there a case where you enable ID on a device first and later turn on TDISP?
I mean, that's going to be the flow in the sense that I expect, well, that whatever connect means to the TSM is at the end of connect, the next thing you can do with that TSM is start binding TDIs. Now, I think there's going to be cases where you do the connect, you bind the TDI, and then something happens, and IDE gets dropped, and then you need to back up and do the flow. But yeah, I mean, trying not to make too many guarantees about what connect means relative to IDE. All it means is that this TSM is ready to bind TDIs.
So Dan, sorry, I lost connection because of driving. It was
No.
going in and out, so I probably missed the last couple of minutes. I think the ID optional makes sense. Like I think you were saying that for integrated devices you probably don't need ID, or most cases don't need ID anyway.
Yeah.
And so what I'm interpreting connect is basically your initial setup of the primary SPDM session between the TSM and the device in question, right? And then ID and TDIS both, whether you're using ID, you would still negotiate ID, do the ID key management over that negotiated SPDM, session anyway. And same for TDIS, right? So ID is naturally optional and can be done if required if it's a discrete device.
Right.
Yeah. Okay. Cool. Thanks. Yeah. I just wanted to make sure I'm synced up.
Yeah. You're back in sync. Yes, and so now Gobi, what you're just asking, like, can can we assume anything about the IDE state? I get maybe I lost train of thought on your question.
No, so I was asking, so the connect, I think Ravi summarized that is really well. So the connect is all it's going to do is to create the base primary SPDM, right?
Right. Mm-hmm. At a
And
minimum,
so if the ID is available, it's going to establish ID right away. Or will there be a flag to connect?
I think it will be not a flag that user space has to present, but it would probably be a flag that the like the TSM driver in the kernel is going to say, hey TSM, I want to connect this device. When I connect you, is IDE going to be part of that or not? And just so it can make it, just so that the TSM driver can make decisions about, because I know it's not specified yet, so like maybe this is getting ahead, but like if we ever needed to do IDE key refresh or something like this, we would, after we do connect, we'd probably set up some kind of timer or some kind of interrupt or something in the driver that says, by the way, you got to come back and refresh this connection every once in a while. That kind of ongoing maintenance task doesn't need to be launched if the TSM said, oh, I connected this without IDE. So I think it'll either be something like an enumeration ahead of time saying, by the way, TSM is not going to try to do IDE for this thing, or it's going to be some kind of something that can be inferred from connect to say, you asked me to connect, and by the way, I didn't turn on IDE when I did that. Something like that.
Okay. So
Yeah.
if I understand properly.
Sorry, I just wanted to add a comment there that it seems that whether to connect, perform the IDE key management setup and connect is really a function of the TSM to decide, because it probably has received some topology that's granted to it from the host, right? And then based on the topology it receives, it can choose to set up IDE or not, and in the end it'll all be evaluated as by the guest as part of the device measurements being verified, right? Because that's what will tell the guest and the remote relying party that it's got a right discrete device connected to it, or a right integrated device connected to it. And if it accepts that device, then it also trusts the TSM to set up the IDE or not, depending on the type of device it received.
Yeah, and the thing I would add, going back to like this idea of do we need to specify IDE or not? I would hope that the expectation is that if IDE is optional, that we just turn it on, because why not? It's really the case of like, if it's not needed, not required, and you can't turn it on, then it'd be nice to know that it's not there.
Right.
Yeah,
And the TSM would have. Sorry, go ahead.
Yeah, there are power and bandwidth implications with IDE, right? So if the IDE is not required, for example, if you have a device that do not require TDISP at all, then why do you even turn on IDE? Some people may not want to turn on IDE.
No, TDISP and IDE are completely orthogonal, right? TDISP is used to
No, you're right. I'm talking about three different cases, right? One, you have a device that has CMA capability. It can provide you the measurements of the device attestation, right? That's one use case. You need SPDM for that. Sure, you can get the CMA without IDE. The second step is where the device do not support TDISP, but it can support IDE. And this IDE could be optional here. Yeah.
Right. But in that particular case, that device then cannot participate in TEIO per se if it doesn't support TDISP.
It cannot,
because
correct.
TDISP, right? So then in that's sort of a no-op for us, right? I mean, if I think the baseline requirement is a device, if it's a discrete device, for it to participate in TEIO, it has to support SPDM, 1.2 whatever derivative, the IDE key management to protect the link, and TDISP, right? If it's an integrated device, it can get away with no IDE because it doesn't have to protect the link. But it still has to support TDISP to be able to like give away TDIs or virtual functions to confidential VMs, right?
The use case, well, I'm hoping this becomes more clear, so upstream understands like why we even try to support IDE without TDISP. But the idea is that if Linux ever needed to support that, or if somebody had a use case for it, like I really need to make sure my link is protected, but I really don't need TDISP for some reason or another, that it'd be nice if Linux could just use this connect flow and not do the bind flow and just call it done, because as far as I understand, all IDE except for on Intel, which you can look at the public spec, requires that you have to talk to your platform TSM to set up IDE, regardless of whether you do TDISP or not. So one of the things I'm deferring to upstream is this idea of natively established IDE that really I only think only one vendor on the planet allows. Everybody else says talk to your TSM to get IDE.
Sure. So yes, if you're talking to TSM, then it needs to be optional, right? Which means that you have to talk to TSM to fetch the CMA measurements. You have to talk to TSM to enable IDE, and you have to talk to TSM to enable TDISP or TIO.
Right.
Now, all these three could be optional, right? And some devices do not. For example, if you take GPUs, NVIDIA GPU, the TDISP or the CC mode is a boot time setting. So you have to boot the device with CC enabled. You cannot toggle that at runtime. So some people may choose to have the device without TDISP at all, without CC enabled, but just with ID enabled. At which point the TSM should not try to enable TIO, but enable ID.
Yeah. I mean, I think at some point it'll be a per TSM decision about whether it requires TDISP or not, and that'll be a per TSM decision. But in terms of what Linux will support the case where Linux should support the case where it's optional and
Hmm.
and allow that. And so so if you find different behavior on different platforms, then that's a conversation between that device vendor and that host vendor. But as far as Linux is concerned, it's prepared for the case where it says, oh yeah, TDIS not required, or I user space is not going to ask for any kind of TIO capabilities. They're never going to bind TDIs here, and let the interface be used that way.
Sure.
But the only implication though is when we do session setup, and because there's only one connect verb, I believe that's the only time people are going to do kind of tdiff like version negotiation. And so I guess all we're asking here for is that the version negotiation is allowed to be like none required or not possible, or without necessarily failing the connect would be Linux expectation.
Doesn't the TDIS version negotiation come up later after the SPDM establishment?
It does come a bit later after SPDM establishment, but this connect verb is pretty coarse grained, and so like the connect might be IDE, might be SPDM, IDE, and TDIS all in one, and all you get is at the end of that is connect pass fail.
Okay, I think that's another topic that we have to discuss down in the future. How do we, when you're talking about TDIS versioning, there are multiple parties involved here. So DSM, TSM, I'm not sure if the Linux host needs to understand the TDIS versioning, but the guest may have to. There are multiple parties involved here, so negotiating a common denominator is going to be a challenge.
Oh, you mean something like the host VMM's like, oh, I negotiated version 4, and then you get to the guest like, no, it needed to be version 5, and so you need to actually
Correct.
go back and reconnect, that kind of thing.
Yeah.
Yeah. I'm hoping that complexity is a user space problem, in the sense that like if I'm deploying my VM image at the at the uh, at the cloud, I specify when I'm on that machine config, like, by the way, this machine is expecting that TDIs are coming in with TDIS version 5, and so you would basically know at config time that this platform is not going to try to we're running rel whatever that still doesn't even know about that TDIS version, so it's not gonna do that.
And TDIS versioning is really a TSM problem, right? I think from a host TSM interface perspective, if there is some versioning mismatch that the TSM found a device doesn't support that it expected, it'll probably just end up returning some error to one of the bind or connect messages, right, from the host.
I think it will, but like I think that doesn't the host have a role to play in the sense of like picking like if there's multiple options, then probably the TSM API is going to say like, hey, if you have a preference, pick one, or at least or basically you have no preference, and whatever's negotiated will tell you what was negotiated. So yeah, like I think it'd only be a problem if there's multiple options and you want to force a negotiation to a specific version just for compatibility reasons. Is that
right?
a use case?
But the watermark would be set by the TSM, right?
The watermark would be set by the I mean TSM ultimately owns how low
Correct.
or high you can go.
Yes,
Yeah.
I think TSM owns it. DSM, they have to negotiate. Yes, I think that is guaranteed, right? But
So
there could be guest that may require specific TDIS versioning. So either they bail out, error out, but the TSM has to expose that. Let me think. Does TSM exposes the negotiated version to the Linux host and guest? Dan?
I don't think so.
I don't
And
know
why
if it
does
has to.
Yeah, I don't think I don't see why the guest cares about the TDIS version. I mean, the guest obviously cares about the authenticity of the device and the firmware version number hashes, etc. of the device. But why does it care about the TDIS? Because that's really a TSM DSM interaction, right? And as long as those two endpoints are happy, why does the guest care? What
It's mostly, I think we have to discuss more about it in the future, but one use case that at least I have in mind is for the device interface report. that needs to be parsed by the guest kernel. The guest needs to know which part of the device memory is T memory, which is non-T memory. You can have the TSM parse it and expose a parsed different a unified structure to the guest. I'll let the guest manage or parse the device interface report. If you're allowing the guest to handle the device interface report, then it needs to understand the TD versioning.
But that could be a version of the device interface report itself, right?
Yeah,
Versus
correct.
version of the
You're
TD.
absolutely right, but we don't have that today. It's built into TD's versioning, yes, and that's a problem.
Ah, that sucks.
Oh,
Yeah.
you're saying that you kind of don't care what the TS version that was negotiated at runtime. Like, kind of doesn't matter. But like, the interface report format may have some new features that you do care about. And you would, if that's available, you'd like to request that one versus like the default one. Is that
Correct. Or could be other way around as well, right? So the current negotiated TD version could be having a new version of device interface report, but which is not supported by the device, the guest kernel. So we have to have the compatibility at the data structure level instead of TD version level.
So it's all like all these data structures are versioned by the top level TDIS protocol version number. Looks like
Yeah.
so.
Yeah.
That's the limitation.
Yeah.
That's such a funny thing because like we as an entire computing industry, we always get that wrong. We always like put version numbers versus like capability lists or things that can grow bigger. Then we always come back like, oh, why did we put a version number there? That's really not sufficient. But it always ends up happening. It's the same problem over and over again all the time.
Yeah.
Okay, but yeah, so yeah, can't resolve it here, but I took a note that we can circle back to this. Yeah, we're getting towards the end. I will follow. I mean, so these night sessions or for U.S. Pacific time night sessions. Going forward, I'm really trying to get like folks like Alexi and Intel folks like How and Yulun on, so we can all just kind of arm wrestle over these POC implementations and get them to a common definition.
Yeah, I tried to get Samuel to join also, but like apparently it's like 3 a.m. or 4 a.m. I don't know in
Yeah, no,
France.
right, no. But this is also why I set up the alternating Europe friendly time. And yeah, so only really dedicated people like Z show up from Europe at this time. but but yeah. So in 2 weeks we'll have the Europe friendly call that will be on a U.S. Pacific morning time. That and we can try to get Samuel there for that one. Yeah, don't make Samuel come to this one. I'd feel really bad.
I forwarded to him anyway just for fun, but
This is fun. Yeah. He would be super dedicated. Yeah. And at some point, I want to have the conversation after we get through the major stuff on this device stuff. I do want to have the conversation with Samuel about next steps for RTMR. Since that's also a cross-vendor thing that has kernel ABI implications that we can kind of talk through. I don't know if we could ever get James Bottomley to join this call, but that's in the back of my mind is probably the next big topic up that's not device security related is because that thread kind of went dark on the mailing list. I think there's it might be something that'd be useful to talk to live about versus trying to continue to go on the mailing
I'll
list.
also note when you're mentioning RTMRs that Google is pretty interested also in preserving access to TPM attestations, at least for back compatibility while we're still doing like rolling out RTMRs. So that is a conversation topic we'll probably also be forcing somewhere upstream as well.
Okay, yeah. Like I've seen rumblings of this. Of like we have SPSM, we have eTPM, we also have RTMRs. Like, and like at least for me, from the upstream perspective, it's like let's build that mechanism and then figure out how these things work together or don't work together. Where you have to do you have to subscribe only to the BTPM universe, or can you also mix in RTMR? I think that's kind of that's the discussion where I think it needs some help from people that are trying to deploy this stuff as well. But other than that, I really appreciate the conversation today, and yeah, we will see you at the next one, which at this time slot will be 4 weeks from now for this kind of evening China friendly, Australia friendly time, and then but we have another call. Our next call will be the Europe friendly time in 2 weeks. Okay, but other than that, thank you and have a good rest of your day or evening.
Thanks, man.
Thank you, Dan.
We'll see you.
Thanks, Dan. Bye.
Bye. Thank you. Bye.
Thanks.